Cameron, welcome to the Democratizing SEO podcast. How are you doing today?
I'm doing well. Thanks for having me. How are you doing?
Yes, very well, thank you. Thank you so much for being on. Today we're going to talk about knowledge graphs, success metrics with knowledge graphs. Now, you're a knowledge professional. How long have you been a knowledge engineer for?
Yeah, I've been working in the space in the industry for about 4 years now. Before that, I had an academic background. I did philosophy, which concentrated a lot on the modeling side, actually, and a little bit of kind of logical modeling and so on, which is sort of the origins of some of these modeling approaches, especially looking at ontologies and so on. And on the industry side, I've worked at a couple of consulting companies. So where I work right now is Crown Point Technologies. We do consulting and services. And I also worked at United Health Group, also in the knowledge space, uh, concentrating on obviously healthcare, health insurance related topics, which is something we support now. So a lot of healthcare, pharma is a common domain that we tend to work in.
I notice a lot of big tech companies are very keen to have academia within their businesses. So they recruit very heavily within that space. Why do you think the academic is very ripe for knowledge professionals? Knowledge graph professionals, I
Yeah,
should say.
yeah, that's a good question. I mean, it is a relatively new technology. I would say it's not extremely widespread in how to develop it and how to do it. So there is probably an advantage if you can find somebody who has some training, at least on the academic side. I'm sure that's one perspective. You're specific to knowledge graphs. There's a number of different approaches, but what a lot of my work is concentrated on is the graph is sort of a data. It's really a database. It's linked data within a database, and there's some kind of model or schema on top of that, and that you would align the data to that really provides a structure and to that data. A lot of modeling approaches have their origins in academia. I do a lot of what's sometimes called ontologies building, ontology modeling, ontology engineering. That sort of comes out of the academic world, and I think that when you're trying to look for somebody, if you can find somebody with that background, it can be an advantage. Now, I will say at the same time, the academic mindset is different than an engineering mindset. So there is a transition that you have to employ. It's not always a completely smooth transition when hiring somebody. You definitely need to give them that kind of ramp up to make sure they understand how to build something for delivery, how to ship, how to understand customer requirements, and so on, which aren't always stressed a lot in academia.
I notice knowledge graphs is such a huge area. I was thinking initially I would say from an outside point of view that, oh, it's pretty much just a small area that's starting to develop. And then I realized actually there are many, many subsets of folks that work around knowledge graphs. So you have knowledge graphs engineers, you have ontologists, you have several different areas that focus on utilizing the knowledge graph technology. What is the difference between an ontologist and a knowledge graph engineer? And you've been both in your career, right?
That's right. Yeah, that's a good question, and the difference will sometimes depend on who you ask. It's to be honest, it's not a once and for all distinction. The way I would break it up in the work that I've done is that the ontologist really focuses on modeling knowledge. So they really want to understand what are the concepts you need to understand somebody's information or their data. What are the important data objects? How do we build a common framework that everybody can understand and everybody can use, and you can agree on what exactly these data objects, or it could be broader, maybe information, what exactly they mean, and what are the important connections between them? For example, if you're interested in the search side of things, semantic search, something like that, one of the things the ontologist would come into is try to understand what are the really important pieces of metadata that any asset you're searching for, what does it need to have to be able to search for it? You might have, sure, there's the title, there might be subjects, there might be keywords, but there might be more, especially if it's a specific system. It's not if it's internal in some way, there might be some specific domain knowledge you would want to build in. But the ontologist really works at this pretty abstract level, thinking about the model, thinking about a common framework for your data or your information assets. The knowledge graph engineer comes in to build a graph database that captures your data and links it together. There are different ways to do this. Often, as somebody who works with ontologies a lot, I like to combine the ontology with the knowledge graph. So I use the ontology that defines a kind of schema that the graph should obey. Like if I've defined out certain connections, if we're building search and I know all the metadata I need the assets to have to find them appropriately, that's gonna then I'm then going to take the actual metadata itself and align it to my ontology I've defined, and then I can make sure everything's represented. Or I could do some fancy analytics and find what assets are similar, something like that. But often I tend to think of the knowledge graph as the implementation when you take the real data and you build a solution using the ontology. Now, I will say, not everybody. You can be a knowledge graph engineer and not use ontologies. There's this whole world as well, I'm sure you've come across, of sometimes called a property graph approach, where you don't really have an ontology per se. You just have a schema that you define. That's a very flexible approach, and it's a little easier to get working. Quickly, you can kind of prototype a little bit faster, but then you don't have that kind of higher level model necessarily. Now, the two approaches are coming together. Many of the big players in both try to get the advantages of each. So, in 10 years, a lot of the things I'm saying may be a little bit obsolete. There might not be as big of a difference. But that's kind of where I see how it breaks down today.
When I think of knowledge graph as a new technology, I think it solves a problem for a business. And then I think, well, what problem does a business have when it comes to data and analytics? Which leads me to the question, what problem does a knowledge graph technology solve?
Yeah, that's an excellent question. Especially, there's such a tendency with new technology to say, oh, this is a new cool technology, so let's adopt it and then try to find a way to use it, rather than think about the problems you actually want to solve and then use the technology to solve them. Absolutely. I think that's a crucial step. Knowledge graphs really excel in cases where you need to link together kind of complex data ecosystems. That's sort of the fundamental value that they bring. And then there's many use cases you can build on top of that, but that's really the crucial thing. So for example, many companies have data silos. They have challenges integrating their data together. It could be for kind of process reasons, like different people own the data and there's a formal process to find out who can access it, and there's security controls. Or it's very informal. You have to find the person find the person in the organization who actually owns it. These are kind of process-oriented reasons that the data is isolated. And then there's sort of, we could say, data schema or database reasons that they're not easy to integrate. Different people have called the pieces of data something differently. What one person calls, in the context of search, for example, one person might have the notion of an abstract. Another person has a notion of a summary. Do they mean the same thing by that? Do they not mean the same thing? Do we need both? These make this kind of integration challenge difficult. So if you have a unified view of what all of your data ecosystem could look like, the knowledge graph can then link everything together into this single space. And you can even, if you have some kind of model about what all your data assets are like, you can even define, security access, or who governs what part of this knowledge graph, who has access to what part. That's still possible to define, partly if you have this unified view of what your data ecosystem is like. Once you can link the data, then that really opens the doors to a lot. There's many analytics use cases you can do now that were very challenging before. If you want to compare, if you might have a company and one part of the company is very doing upstream processing of some kind, and another part is very downstream from what they're doing. You want to see the performance as it shows up in the downstream group based on what the upstream group did. If they're very siloed, it's very hard to do that. You're gonna pay some data engineers a lot of money to gather that information together and do some analytics. If it's linked together, that's really a matter of just querying this unified database. Similar thing, I think I would say similar remarks for kind of search context too. If you have all your assets you're searching against, and the metadata for them is sort of unified in a single structure, search problems can be a lot more manageable in that context. If everybody sort of labeling things differently, they're using different categories, search becomes very hard and it can be challenging in that context. So this unified way of linking everything together really enhances, I think, search as well. But it's that data integration is kind of the fundamental piece to it.
You see, I am extremely fascinated with knowledge graphs because coming from an SEO search point of view, I see a lot of changes happening within the search space. And with AI now very much coming to the forefront of the general mass media, let's say, I can see where things are headed, where in order for search users to be satisfied, search engines and big tech overall really need to have access to the facts about entities, brands. And all of this is leading me to think, if an entity is not easily accessible, it's going to be difficult for the search engine and or big tech to provide that to the end user when they search for them. In other words, those who make it easier, those brands, entities that make it easier for them to be discovered will be shown to the end users. Am I way off in this thinking, or is it close, far, nearby?
No, I think I exactly agree with you. I think that really makes sense. If you want your information, your website, or whatever to be found by a search engine, you need to make yourself accessible to that. And part of making yourself accessible is, I like what you put it, is they need to have access to your data objects as an object, not just as kind of labels or text or strings somewhere, but they need to be able to have a view of your information that really treats it as an object that knows about, we have this graph, and in the graph, there's this concept of let's say a person, and then Austine and Cameron are different people, and they're treated as objects. It's not just strings in a column or something like that. And then we make those links outwards. So we might say, well, Cameron created this asset, Austine created this asset. Those were created at a certain time, and they might have a certain subject associated with it. So this is a really kind of enriched view of things, where you have a schema that's kind of trying to really represent the reality of how these assets are linked, capturing things like who the people involved are and what they did related to their assets. And you have to make all of that accessible if you want it to be found. I know Google has done an amazing job with the new Google Knowledge Graph, which is really put the term on the map, and making yourself accessible to Google's Knowledge Graph is one of the kind of key things for the SEO world. If Google can kind of understand your information that you have that you want people to find, they need to be able to put it into this model and be able to know where the different pieces of metadata or topic information, where that fits into their structure, so that people that can then search against it.
I want to talk about metrics that an engineer may consider when you think of or when you're working rather on a knowledge graph. As an engineer, what are some of the metrics that you see as success milestones, or even success metrics itself?
Yeah, that's a good question. I was thinking about that a little bit because it's one of those. It can quickly become one of those things where you sort of know it in the back of your head, but then making it explicit is an interesting exercise, right? So I was thinking about that a little bit. Um, I think we can divide the success metrics into two categories. It's sort of like solving business problems as one kind of metric. And then there's like engineering best practices. Just in general, how do you make a good, robust, scalable, sustainable knowledge graph? And you really need to balance both of those. From a business solutions point of view, I mean, the process is probably fairly typical to most tech solutions processes, where you identify the problem, you identify the pain points, and then you think about what would be like a solution use case that would solve that problem. So if we're talking about search, I mean, the problem is it's hard to find. People sometimes find it hard to find the information they want. There's so much information out there. You need to weed through it. Meeting the people who want, the information producers and the information consumers need to meet somehow. And there's a lot of both of them. So it's hard to make them meet. So the solution to this, right, is to have some kind of search system that an ordinary person can navigate. They can use it easily, and that they know how to put in the prompts that they want to find the information back that they want to. And then the flip side is also true for the information producers. They want to understand how the system works so that they can make their information findable by the type of people they want it found by. Now that is still high level. We have a start of a solution, right? But that's still very high level. How does the knowledge graph come into it? So then we need to define what are sometimes called competency questions or business questions. These are more specific questions about how exactly you want the knowledge graph to perform. And it's really like, what questions should I ask it? And then what answers am I expecting to get from those questions? That's really, I think, the key way that a lot of engineers try to think about building these systems. And when I say asking questions, that could be, that used to mean you would translate the question into some kind of a query language, and then that would go into the database. Increasingly, that's a place where Gen AI can actually come into the middle. So one area that Gen AI has proven to be pretty useful actually is translating from a kind of just ordinary language question into a structured query language. But yeah, some examples of these more specific ones would be things like, if I want to find information about a particular topic, maybe my question is going to be, I'm going to search some description of that topic or just the name of that topic, and then what specific metadata am I expecting to get back? Am I expecting to get back just hyperlinks? Am I expecting something like the Google Knowledge Panel that has kind of summary of the topic? Am I expecting there to be an order like the more recently updated or the most popularly updated or something like that? So there's a pretty specific expectation about what you want to get out of the system. And that's really crucial, I think, for evaluating whether it works well is you need these, pretty specific expectations about what you want it to do. And then you test it, and it probably won't do exactly what you want it to do at the beginning. There's some rounds of development and so forth. But really, I think defining these pretty specific competency questions is crucial. So that takes a lot of kind of requirements thought to think about how you go from a general problem to what a solution might look like, and then to specific semi-technical questions about how you want the system to work. There's also like a best practices side of things. So you can't, when you're building these systems, you want to follow, of course, best practices engineering tools. One thing you want to think about is, you have to work step by step. So how do we come up with a process that we can like deliver value over time, and we can continue this process, but recognizing we can't do everything all at once, all at the same time. So there's a number of standards in the knowledge graph space that really help with that. Because everything is interconnected, as you add more data to your knowledge graph, you're adding not just connections, but you're adding exponential more connections. Everything new that gets added could be connected across any number of dimensions that you want. with the data you already have. So things can grow really fast. So when building things, we want to think about things like, well, how do I extend it? How do I make sure it stays interoperable with new information I get? Interoperable meaning it might, I have a model now, but somebody else might have something different that doesn't exactly fit into my model. Do I know how I'm going to map into my schema or my model? Do I know how I'm going to extend it? If new people come in and they want to use my system, how easy is it for them to understand how things were put together? We often try to use open standards. That's very common in kind of the ontology side of things. It's very built around open standards and a number of kind of common modeling approaches so that everybody knows what to expect. But yeah, I think all of that kind of goes in. I'm sure if I sat down, I could think of more, but I think all of that goes into, how you define success for a knowledge graph, how you define that kind of process of development over time, since you can't do everything all at once. My own work, the way we like to work, we really like to try to get something to the user and almost as quickly as possible, even if it's really a prototype, it's a proof of concept, it's not something they would really use, but getting something the user can use and then seeing their feedback, seeing their interactions with it is a really important way that we work. So we try to be quick to prototype, and then from prototype quick to the next step, something, an MVP, dev level MVP, something like that. We try to move quickly to stages where the user can use it. That feedback, I think, is so crucial that you don't have until you really have something that they can use.
When a business is interested in a knowledge graph technology, and let's say the business has 5 different departments that has data in different ways, right? And you're trying to pull all of that together. How do you encourage each department to cooperate and allow a knowledge graph technology to be built using their data?
Mm-hmm. Yeah, that's a good question. I mean, when different people are at play and they might have different incentives, different motives, obviously there's a challenge in getting them to all come aligned and come to work together. I think we've found a lot of success in defining a fairly narrow business problem that has appeal to all of the stakeholders that you need involved. So, for example, really good examples are ones that they are kind of mutually beneficial, where it's not, I use this idea of data producers and data consumers before. It's hard if you build a big solution, and it might take up a lot of people's time if you need to get them involved, and they might lose, they're worried they're going to lose some ownership of their own data. That's going to be a hard sell if they're also not really going to get anything out of it at the end of the day. They're just a producer. Somebody else is consuming downstream, let's say, what they're putting into this knowledge graph. So it really helps if you can think about use cases that do cross these departments, cross these parts of the organization. And that's, I think there are many of these problems. Maybe people don't always think about them because they sort of assume they're stuck in these kind of silo worlds. But there are many of these problems. So, for example, I mentioned, I think maybe really early in the call, manufacturing cases are really common ones where there are data silos, but everybody would benefit from a better view of things. So, you always, nowadays the manufacturing process is really complex, and there's many people involved in that process. Somebody early in the process wants to know what's happening later in the process, and vice versa. And if you can bring their data together and both of those people can use it, that's really powerful. And that does bring people to the table and want to get them involved. And if you can show them, I mean, we try to define, some specific, these very specific questions that competency questions or business questions I mentioned. Try to find ones that are really hard for them to solve today. And if it's going to take a data engineer or two a few weeks to answer this question, that takes time, that slows the process down, and it's really expensive. So if we can solve that fast, then that really brings people to the table. I think, in the search context, I think we can imagine these kinds of cases too. I mean, many organizations, I'm sure, different groups of the company have information everybody else needs, and putting those into a place that everybody can find it is really important. And I know these kinds of search cases are another things that organizations really care about. Partly they don't want to put it up just on the web so you can use Google to find it, because it might be proprietary. It might be, they don't want to share this stuff. So they need their own solution. And they're not, they're not search experts. So they need a new solution to build that out. So I think there are these kinds of use cases that cross department that are of interest to everybody are really the crucial ones.
Yeah, you said it right there, and it relates to what I am seeing on the web as well. Knowledge graphs for the use case of web discovery. The one commonality everyone has on the web is discovery. They all want to be discovered. And you also indicated another word, which is relating to speed, right? How quickly can you discover information? The idea of having data providers and data consumers collaborating for the use of being discovered, that's pretty much the web, right? If someone doesn't want to be discovered on the web, they wouldn't be on the web, which is interesting to me and leads me into looking into the value of search, because central to all of this discovery is being searchable. And when I think of search the way it used to be, search used to provide search results. Now, however, I'm looking at search as something that provides search answers. And the difference, the way I see it in my mind, is results has a barrier to it, which is the end user, the data receiver, has to carry out more time searching, researching, going over the 10 results and seeing which one is best for them, even if the 10 are listed in order. Whereas answers provides precisely what they're seeking. And if it's not precise, the onus is on the searcher to refine their search in order for the data, in this case, Google, the data holder or the person in between the data provider and data consumer, to provide the data consumer with precisely what they're seeking. Does a knowledge graph help with search answers? Not necessarily results, but search answers.
Yeah, that's it. Yeah, it's a really interesting way to put it, because that's certainly true that's been a big transformation. The user doesn't just want a list of websites or a list of documents. They want information. They want them to know what the answer to their question is, which makes sense. I mean, that you search the websites and the documents because there's information you want to have access to. It's not the sites themselves; it's what they contain.
Yep.
So the quicker search can provide the person what they want, then of course the better, and that brings about a greater solution. Yeah, these kinds of approaches, where a knowledge graph could come in to, not just deliver them the location of a website or document, maybe some metadata about that, but being able to answer their question. Certainly there's a lot of work in this area to be able to provide those answers. One place that this can show up is you can have text in a knowledge graph as well. So you don't just need to think about modeling, spreadsheets of, numbers and so on, but you can put text in a knowledge graph as well. I've even seen cases, I don't think I've worked on this very much myself, but some peers are working on cases where you can break down structurally what a document is in terms of the different parts of that. And that can be put into a knowledge graph. You could have metadata tagging the parts of these texts. Now, accessing the information, that can be tricky. That's when you would need something like, it used to be a natural language processing system. So it would find the right text, and then it would need to, process that text in some way, and then maybe deliver it, or at least interpret it to know it was the right kind of topic. But this is also, I think, a very powerful place where Gen AI can come in as well. So a knowledge graph could structure all of this text, all of this unstructured information, provide some amount of structure to it in terms of, relating where relating the metadata of these documents, and also bringing in, could be topically keywords or subject or something like that. And then a Gen AI system can sort of query the knowledge graph. It kind of finds the right information, and then that could present some answers to somebody as well. So in this context, the knowledge graph, what we would really be doing is presenting the information in a really easy to find way for the Gen AI chatbot, which would then provide a kind of interpretation layer to read the text and then present it in a way that would make sense to the user. This area, obviously, it's very new. Gen AI has only kind of recently been up to the task of doing these kinds of jobs. So this is definitely an area where many people are excited about what exactly you can do with that. I know I've seen kind of on the internal to different companies, they've certainly found a lot of help with a knowledge graph that organizes their own kind of documents or reports, that's a lot of information that organizations keep are these unstructured reports. They're not broken down into a table where you can quickly ask for it. And putting these into a knowledge graph and then having a Gen AI chatbot access to the knowledge graph is something we have seen a lot of success. That's something a lot of companies are getting very interested to. It's a work in progress. There's a lot of research that needs to be done, but I think we are getting closer to this kind of almost dream that people can imagine, a plugin or a web portal or something where they just ask a question and it in natural language, and it goes through all the information through their company to try to find the right answer to that. It's a lot of work to get there, but the tools are coming into place to being able to do that.
That is what I'm seeing on Google themselves, as well as chatbots, because someone and also the devices used to search for information, i.e. being on a mobile device, right? Most search is carried out on mobile first now. And if someone is on the go, let's say they're driving and they want to find the answer to something, and they use either Google search or some sort of AI chatbot, they don't want a list of stuff. They want the exact information that they're seeking. And they expect the service that they're using to have and provide that information, which is why I believe over the years, we've seen an increase in Google providing the precise information that someone wants on the SERPs itself, rather than having to land on a site, a page, and then search for the information that they want. That's taking way too much time, in my opinion. As an engineer, a knowledge graph engineer, when you use the web, can you sort of like get a sense of the machinations that's happening on the back end when you use something like Google search or a search platform to find information?
Yeah, that's a good question. I don't know if I've thought about it that much. I do have an idea about how Google has structured. I mean, they've been somewhat open and then somewhat not open. I do have an idea about how they've structured what their graph exists from, and you can kind of make some assumptions that from the knowledge panel itself, you can kind of see these are the main attributes that they're tracking. They've been pretty open. Well, they've been involved in the standard schema.org. So you have some idea about at a general kind of standards or industry-wide level, what kind of models that they're using. But I'll also say, the technology does change very quickly. The capabilities change very quickly. And I am often kind of surprised about new things that come out. So I don't know if it is actually always that easy for me to tell sort of how it's working under the hood, so to speak, without some amount of guidance on what they're doing. That can sometimes be the kind of the magic of these tools, is that, even I've seen other complex kind of knowledge graph projects where I'm a little, I can, I might be closer to actually being able to kind of query the system, but really knowing how it's structured takes either a lot of time or somebody needs to kind of explain it to me there. I think a lot of technologies like that, but that could be a function of how these knowledge graphs work. I mean, you have a complicated web of interconnected objects, and sometimes the question you're asking is taking this very complicated path through all these different connections. It might not be easy for just the user, even if they have some expertise, to know exactly how to do it. They might have an idea about one way you could do it. But it is interesting. It's not, I personally at least don't always find it that easy to tell under the hood what's going on.
As an SEO, if someone were to ask me which search engine do I use most often, I would have said Google, but I've been thinking about it recently. And actually, I think my use case determines the engine that I use. I spend a lot of time on Google still, but also YouTube, TikTok most recently, Amazon for e-commerce. And what I'm noticing is, as time goes on, I don't think let me rephrase this. Google is still my default search engine, but I don't necessarily go to them first for search. I think of what I want to search for and then decide on the best platform to search on. And as time goes on, I can see myself spending more time on chatbots because of the speed of delivery of what I'm searching for. Do you sometimes think search is bigger than one particular company or search engine? And I ask this because the more I explore my search patterns, the more I'm realizing social media has a huge search functionality, and I used social media for search: YouTube, TikTok, other platforms. Are we sometimes SEOs too narrowed into one particular search engine? And do you think the use case will determine the way the general public search in the, let's say, next 5 or so years?
Yeah, that's also a really interesting point, and that lines up with my own experience as well, that the specifics of what you're searching for, the information you want, really can dictate the kind of tool that you could use. And partly I think that's a reflection that specializing, search is such a big problem case that people who specialize can outperform, right? Amazon has really been one of the most amazing search platforms that there is. I mean, not only finding things you're consciously thinking about, but how good they are at sort of showing you, well, if you're interested in this, you might be interested in that, coming up with recommendations, the timing of those recommendations with when things, the prices of things might drop, for example, or seasonally when you might want those products. I mean, they've been extremely successful at leveraging but they also have a knowledge graph of their products, and then leveraging that to produce, user prompted search, but then also just different ways of information delivery. And they've really specialized in e-commerce, and that's made them really successful. So I definitely agree with that. I think SEO experts certainly need to think about, what's the use case? There's more search engines than just kind of the general web search engines like Google. You're right that other sites, other tools can function as search engines. It's also interesting to think it's not just a topic question. Like if I'm looking for e-commerce products, I might go to Amazon. If I'm looking for like user generated content, that's less the topic I'm looking for, and that's more the source that it's coming from, who's producing it. Where social media is really, that makes it very easy for people to make their own content. It's not so common that people make their own websites anymore. That's very, really to a small professional now, where not like it used to be in the 90s, right, when everybody made their own websites if they were online. But social media now, that's where ordinary consumers make their own content. For myself, if I'm looking up information about like a local business, I would look that up on Facebook. Local businesses have stronger if they're smaller, they have stronger representation, I think, on social media than they would on like a site that Google finds. So that certainly accords with my experience. And I certainly agree that, yeah, I mean, that's interesting. Some tools, it's easier for the data producer to put their information out on, right? Like social media makes it very easy for the ordinary person to produce information in that context. So, thinking about where the data is natively getting produced, if it's TikTok, if it's Facebook, targeting that search engine will be really important. And then, for certain areas, domains, Amazon is going to outperform, I think, on e-commerce a lot of the time, a more generic search engine, because they can just target their focus. They already are filtering to what their topic they're concentrating on. So yeah, I think I agree with you. That is a really interesting point about SEO is not just general web search engines anymore. I think it's now there are any number of different tools to search for any number of different topics that we have to think about.
They're fascinating times ahead. I think search is continuing to expand and get more comprehensive. And to me, it just ignites all the creative indicators in me, because it continues to amaze me. I want to get your thoughts on the idea of live content. In this case, let's say live data. And so a background to this is I'm interested in the idea of live, or should I say, these big tech companies providing live capabilities. So someone on social media, they can go live on Facebook, TikTok, what have you, YouTube, etc. When it comes to knowledge graph engineering, my thinking is there's almost like a two-step process. You grab the data first and then you utilize it. When grabbing the data, it means you have to have the data in the first place. We now have the ability to have live data, right? So essentially, this deals with current information rather than a data which has already been made in the first place. So a data provider provides data in real time. How do you guys account, you guys being knowledge graph engineers, account for live fed data?
Yeah, that is a really important and challenging problem that takes a lot of thought. Like you're exactly right that I haven't thought as much or worked as much with kind of live, let's say video content or real, like what we think of as user generated content. That is a really interesting case. But certainly when you think about data in general, people want the most up to date data today when they want to solve their business problems. They don't want, the system was updated, we have to check when it was. If it's a slow system, that could be a really big problem. Certainly getting the most up to date or live feed on what the data actually looks like is going to be important. And that can be a really technical problem. You're right that the process does kind of proceed in these two stages. You ingest the data into the knowledge graph, and that partly will involve this kind of aligning things to the schema or the model that you're using. If you're using an ontology, you need to map that into the ontology terms and definitions that you're using. And then once that ingestion is done, you can ask the knowledge graph the question. We have seen a lot of, there are tools you can set up where you can have live connections to other databases, and they can be kind of triggered to refresh when the other databases have been triggered to refresh, for example. So in the way that this would work is you have a kind of general mapping from what one database, what its structure looks like, into the knowledge graph structure that you want. So if I'm calling out, one actually search is an example where I've worked on this topic. So working just at an internal search for an organization, they had documents stored in all these different kinds of repositories. Some of them were even custom made. Some of them are things like SharePoint. And one of the goals of using the knowledge graph here was to pull all of the documents in terms of their metadata, not not the documents themselves, but registering all the metadata about these documents. And then there can be triggers set up so that this mapping system is kind of universal. So if somebody uploads a new document, we already know where all the metadata from, let's say, SharePoint is located and how that's going to fit into the knowledge graph. But even that can be too slow. If the updating, if it's too much data, that can be too slow. So there have been some other techniques, sometimes called virtualization is sometimes the term it's used, where you don't actually put the data in the knowledge graph. What you do is you have this general mapping, like I mentioned. So I know how the data in this system would fit into my knowledge graph. And when somebody's asking the knowledge graph a question, what the system is actually doing is on the fly, it's grabbing the most recent data in this external system and then applying the mapping and presenting it to the user as sort of as though it's all integrated in the knowledge graph. It's kind of making those connections on the fly. And there are some new tools that are able to do this pretty successfully as well. But to the user, it looks the same. It looks like everything is just in the database, but there really is kind of behind the scenes. There's kind of on the fly calling to a different system and pulling in what's relevant in that system and then aligning it into your knowledge graph on the fly. We found some success for that. And the user often, they have no idea one way or the other. It looks to them like all of the most recent data is in the knowledge graph.
Virtualization. I haven't come across that before. I'm going to do my research on that. That's a very interesting concept because I think that's where we're headed. Everything is going to be real time. Seeking information. I notice it myself when I search for certain things. I want the most up-to-date information. And every now and then I come across the platform that I am on doesn't have the most recent information. So I go to one that I know has tons and encourages folks to go live often. And they have the information. And the more this happens, the more I'm keen to use this other platform rather than the one I am used to. So the whole idea of virtualization, that's it. I think I'm going to have a topic on that because that's super, super interesting to me. Cameron.
Yeah, I think that's where things are going to need to go. There's people can update so quickly and there's so much out there. It's not going to be scalable for it all to just be kind of updated. Every system needs to be updated all the time. I don't think that's going to be scalable. It's going to have to be something that's on the fly, kind of, virtually presenting the data on demand. That's going to have to be, I think, the way to the future.
Totally. Cameron, every business should know this about semantic search. What would this be?
That's a good question. I would say every business needs to have a really good understanding of the problem space that they're trying to solve before they start using semantic search. Projects that start generically, like I want to find information faster, are usually not successful. It needs to be, I want this person, I have personas, I want this person to find this information for this particular reason. Projects that are defined like that are likely to be so much more successful. And once you make those clarifications, then you can really, it's really a matter of kind of semantic search engineering to know what the tools are, what does it need to be built, how do I go from there? And there are specialists that you can contact. Certainly I'm happy to be reached out to contact to go from there. But the first step is a crucial one. And that's what business needs to identify first is what's the problem? What exactly do I want my users to be able to do in terms of finding the information that I want? And then we can build from there. That's really, I think, the crucial way to start these projects. If they want to kind of encapsulate what can semantic search do for them at a general level, and what should every business know, I would say semantic search builds upon traditional search by having a consistent model for understanding what all the metadata means for their assets. So meaning not everybody can put in anything that they want. They can say subject, they can say abstract, they can say summary, but there's a consistent model everybody has to follow to be in the search system. And it's a clear definitions and clear understanding what all these metadata categories mean. I think that's something accessible to everybody. We don't need to get into the technical structuring of how this would work and the modeling and the queries and so on. But at that high level, I think every business should know how they can use semantic search from there.
Cameron, thank you so much for your time today. Where is the best place for folks to find you online?
The best place would be on LinkedIn. If you search Cameron Gibbs, there are a few, but if you add ontology or knowledge graph, I should come up. That'll be the best place to reach out to me. I'm happy to talk. If anybody has any projects they need help with, any advice they need getting started, certainly we can offer them help. We can give them advice. That's the best place to reach me though, is just on LinkedIn. I'm sure we'll have the link for that below.
Yes, I'll definitely add that below so folks can get in contact with you. Cameron, thank you so much for your time, and I'm sure we'll catch up again another time.
Absolutely. This has been great. Thank you so much for having me.
Pleasure. Thank you. Cheers.